Good morning, Math 2. We are continuing on in our triangle congruency unit. If you look at your 90-day pacing guide, we are off on the dates, but today we're starting similar polygons. It's a 2-day topic, so there will be a second video with the more algebra portion of this, but this is just the first introductory video. Of course, I'll post the blank notes and then a filled-in PDF of the notes as well, and the practice. So follow along with me, please. First, defining what a similar polygon is it's a polygon with the same shape but a different size. We can determine if the polygons are similar if their corresponding angles are congruent. So their corresponding angles are congruent, and that means that the corresponding means the angles that line up with each other. They are the exact same. If one's 30 in one triangle, it'll be 30 in the other. And then the corresponding sides are proportional. So proportional means that they're not both 6 inches long, but all 3 sides of a triangle will grow to be the same proportion. So if one side is 2 times larger than the other, all 3 sides have to be that same ratio. This ratio is called the scale factor. If polygons are similar, then their perimeters are also proportional. Alright, let's look at some examples. The first 3 questions in your notes are talking about the scale factor. How much does it grow or shrink by? We actually talked about scale factor back in Unit 1 with our transformations. Remember, it was with the dilations. If it was a fraction, that was considered a reduction, and then if it was a whole number, it was considered an enlargement. Same idea here. So for the first one, it says, what is the scale factor of ABC to DEF? So they want ABC on top, so we're going to pick one side on triangle ABC, so we'll put 8 on top. And then it has to match up, so I picked the side in between the angle marked with 1 line and 2 lines, so that's going to be side DE. So 8 over 12 is the scale factor. Of course, we can reduce both of these by 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3. So your scale factor is 2/3. Again, I could have picked a different side. I could have started with BC over EF, and again, that will reduce by 5 to 2/3. So it doesn't matter which sides you pick, you just want to make sure they line up. Another way to make sure that they line up is looking over here. The first 2, AB, will go with the first 2 here. So AB has to go with DE. The first and the last, AC, has to go with D and F. Sometimes the triangles are turned, so sometimes they won't perfectly line up. The sides won't perfectly line up with that. Alright, the second question asks, what is the scale factor of triangle DEF to ABC? So DEF goes on top. So now, this time, I'll just use the same sides. 12 will go on top, and then 8 goes on the bottom. So now your scale factor is 3/2. Alright, last but not least, for scale factor, they want you to add up all sides in the first triangle. So we have 8 plus 10 plus 14. So this one's going to be 32 for the perimeter. They want the scale factor for the perimeters. Then you're going to add up all 3 sides of the second triangle. 12 plus 15 plus 21 is 48. So then it starts with DEF, so that's what we want to put on top. So 48 goes on top, whatever's listed first goes on top, over the perimeter of triangle ABC, 48 over 32. Alright, don't forget to reduce. If we reduce, this one will reduce to 3/2. And don't forget about that math frac button in your calculator. To give you the most reduced fraction. Okay, moving along. The symbol for similarity is just a squiggly line. The symbol for congruence is the squiggly line above an equal sign. So that's the difference. So we know that these are, you would want to check all 3 sides and make sure they all have a ratio of 2/3. which we already checked the 10 over 5, the 14 over 21 would also follow that ratio. So we can say that triangle ABC is similar to triangle DEF. Put a little triangle in front of that one. All right, number 1. List all congruent angles and write a proportion that relates to the corresponding sides. Okay, so this is important and it will help us with when we get to the algebra problems. But number 1 is saying that triangle JKL is similar to triangle PMN. So again, the order matters. This triangle has obviously been turned. We don't know if K goes with P. One of these could be turned. So you really want to look over here. So angle J goes with angle P. So they have been turned, which makes it confusing. But these two angles here are congruent. I'll mark them with one line. The middle angle K goes with the middle angle here, which is M. I'll mark those with 2 lines, and then the last goes with the last. So the L goes with the N, and I marked those with 3 lines so that I can easily look at my picture and know which goes with which. So let's go ahead and say angle J is congruent to angle P. Angle K is congruent to angle M. This is all they want us to do here, is just list out what matches with what. You get that from the ordering of the statement. Last one, angle L is congruent to angle N. Now the sides, I'm going to go ahead and mark them. And again, you can first 2, side JK, that's right here, has to go with the first 2, which is PM. So then I find PM and I mark it here. So we'll say side JK is similar to side PM. All right, then we will say KL, which is the last 2, I'll mark it with 2, goes with MN. So you can look up here for the ordering of the letters. I picked the last 2 here has to go with the last 2 here. KL has to go with MN. Or I can look down here and see that this side is in between the 2 lines and the 3 lines. So then this side would match because it's in between the 2-lined angle and the 3-lined angle. So side KL is similar to side MN. And then last one, side JL, is similar to side PN. JL and PN. First and last, first and last. All right, number 2. This one's a little bit easier, and we'll write this more as proportions. The angles do match up with each other. So angle X is congruent to angle R. Angle Z is congruent to angle S. And then obviously angle Y is congruent to angle Y. Angle Y is in both of them. So angle X is congruent to angle R. Angle Z is congruent to angle S. And last but not least, Y is congruent to angle Y. And remember, in similar triangles, the angles are equal to each other. If angle X is 45, angle R is 45. The sides are not equal. We're looking at this smaller triangle, comparing it to the bigger triangle. Obviously, side RY is not the same length as XY. So, again, this one's a little bit easier to see which matches up with which because it's a triangle inside the triangle, but if you're confused, just look at the ordering of the letters. XY, this whole side here goes with RY. So we'll write it as a ratio here. We'll write XY goes with RY. Then we can say ZY goes with SY. Just if I stick with the bigger triangle on top and the smaller triangle on the bottom, I want to stay consistent with that. And then last but not least, RS goes with XZ. And I'm going to put XZ on top actually because I started with the bigger triangle the entire time. All right, flip to the back. I'm going to let you try 3 on your own, but let's go ahead and try a couple of solving problems. I'm going to do 4, 6, and 8 with you, and then I'll post the answers to the rest of them. All right, number 4. Also, by the way, YouTube does not let me post videos that are like 20 minutes long, so that's why I have to keep these short, and I think you would want that anyways. All right, number 4, we have a scale factor of 2 to 3. That's the ratio. You could also write it like that. So to solve for the missing side here, we know it has to grow, or the scale factor from this one to this one is 2/3. So let's go ahead and set that up. We'll put the smaller triangle on top, since the smaller number's on top, and we're going to set it equal to the scale factor. This is how you solve a problem when they give you the scale factor. Then you're going to cross multiply and solve the equation. So x equals 63. If they don't give you the scale factor, you're still going to create proportions to cross multiply and solve, because we know that they grow. These are similar triangles. Each side has to grow or shrink by the same amount. So for number 6, it doesn't matter how you start. I'm going to start with the bigger triangle. I'm going to put AB. X has to go with the side DE. I'm looking at the first two letters here. AB goes with DE. You always want to look up here. Don't look at the triangles because they're turned. The ordering of the letters is very important. So I'm going to put x over 25. Then I'm going to set it equal to, go back to whatever you put on top. So I'm doing big triangle over small equals big triangle over small. Then you're going to cross multiply. So we have 20 times x is 20x. Then we're going to set it equal to 25 times 28, which is 700. Divide by 20, x equals 35. And that's all the question asks. Find the value of x. So for these problems, you're always cross multiplying. They might have a little bit more intense solving, like number 8. Again, I can obviously tell these have been turned, so I'm going to focus my attention up here. I'm going to stay consistent. I'm going to start with putting the bigger triangle on top. So I'm going to start with AG, so that's 32, has to go over kx, so now I find kx, which is x plus 3. And then when I set up my next fraction, I have to go back to whatever I put on top. So bigger triangle has to stay on top. You don't have to set it up that way. If you do bigger over smaller, it has to be equal to bigger over smaller. You could have started with smaller over bigger, just set it equal to smaller over bigger. Alright, I'm going to put these in parentheses so that when I cross multiply, I can set up an easy equation. So it's going to be 36 times x plus 3 equals 32 times x plus 6. Then you're going to FOIL out each side and solve. This is not the hard part. The hard part is paying attention to the letters and matching it up with the correct side and staying consistent with what you put on top. Remember, I put big triangle over small equals big triangle over small. Then you cross multiply. Okay, now we get 36x plus 108 equals 32x plus 32 times 6 is 192. Okay, so now you're going to get your like terms. So I'm going to subtract over my 32x, keeping that x positive. And then I'm going to subtract over my 108. So I'm going to get 4x equals 84. Divide by 4, x equals positive 21. This just said find the value of x. If it said find the length of the missing sides, then I'd plug in my 21 here and get 27 and 24. But in this case, they just wanted the 21. Alright, so that is your similar triangle notes for today, or I'm sorry, similar polygon notes for today, and setting up your fractions is what you're focusing on. So go ahead and try a few of these and then check your answers with the answer key online. We'll look at more problems tomorrow.